This video is sponsored by Brilliant. You guys, this looks like a fun one. We're given a semicircle with points that are equally spaced on the circumference. We're also given that this has a length of 3. And the question's asking, what is the total shaded area? This is day 20 of the 2025 Advent calendar. And if you want to try this one, pause it right now because I'm going to solve it in 3, 2, 1. First, let's label the center of the semicircle, and then let's connect all of these radii to the points that we were given. Since each of these arcs are congruent, that means the base angles will also be congruent. And inside of a semicircle, all of this will add up to 180 degrees, which makes each of these 30 degrees. And I want to focus on this one right here. From this point right here, let's drop this segment perpendicular to the diameter. And now we have a nice looking right triangle. And since this is 30 and this is 90, that means this last angle has to be 60. So we've got a 30, 60, 90 triangle. Now we do know the base of this triangle. Since this whole thing is equal to 3, this is going to be half of it. It's going to be equal to 3 over 2. And then in every single 30, 60, 90 triangle, the hypotenuse is twice as large as the smallest side, and the medium side is square root of 3 times the smallest side. That means if we know this side, we can divide by square root of 3 to get the shortest side. So this side is going to be 3 over 2 root 3. And then we can simplify this a little bit. The 3 on top can be broken down into root 3 times root 3. And then this root 3 on top and this root 3 on bottom are going to cancel each other out. So the height of this 30, 60, 90 triangle is root 3 over 2. And then to get the hypotenuse, we end up multiplying the shortest side by 2. And root 3 over 2 times 2 is equal to root 3. Let's bring back the rest of the radii and let's bring back the original here. Now let's find the area of this lower blue region, and we can start with this sector right here. These are the notes for the area of a sector. We know that the area of a sector is the central angle divided by 360 times pi r squared. So in our case, we know the central angle is equal to 30 and the radius is equal to this hypotenuse, which was root 3. So now we have the area is equal to 30 over 360 times pi root 3 squared. This square root and this square can cancel each other out, and we can bring the 3 up here. 3 times 30 is equal to 90, and 90 divided by 360 is 1/4. So the area of this sector is equal to pi over 4. And the same thing is going to happen over here. This sector also has a central angle of 30 degrees and a radius of root 3. So the area will also be pi over 4. And then now from here, let's focus on this blue triangle here. The area of a triangle is 1/2 base times height. We already know the base of this triangle is equal to 3, and the height of this triangle is the same thing as the height of this triangle. It was root 3 over 2. And now we can clean this up. In the denominator, 2 times 2 is equal to 4, and on top, 1 times 3 times root 3 is equal to 3 root 3. And that is fully simplified. That is the area of this region. And now we have the area of this whole bottom blue piece. It's equal to this plus this plus this. And we can rearrange things a little bit, and pi over 4 plus pi over 4 is equal to 2 pi over 4, and that simplifies to pi over 2. So the area of this lower blue region is equal to pi over 2 plus 3 root 3 over 4. And now we can focus on the top region. Let's make a copy of this down here. Let's bring in these 2 radii for both of these. And for the top one, let's find the area of the entire sector. And for the bottom one, let's find the area of this triangle. Now we have a way to find this blue area. It's going to be this red sector minus this green triangle. First, we can find the area of the red sector. This central angle is equal to these two 30s. It'll be 60 degrees. And then this radius is the same thing as this radius. It's root 3. And now we can use these notes again. The central angle is equal to 60 degrees and the radius is equal to root 3. When we simplify this, root 3 squared is equal to 3, and then 3 times 60 is equal to 180. And 180 divided by 360 is equal to 1/2. So we end up with the area is equal to 1/2 pi. So up here, let's label the area pi over 2. And then we can find the area of this green triangle. The area of a triangle is equal to 1/2 base times height. First, we know this angle is equal to 60 degrees. And then since both of these are radii, we know that this is an isosceles triangle, which means these two base angles have to be equal. That's called the base angles theorem. Here's the notes right here. Anytime you have two congruent sides of an isosceles triangle, the angles opposite those sides have to be congruent. So in this case, these two angles will equal 60 degrees. And since all 3 angles are congruent, that means all 3 sides are congruent. So we know the base of the triangle is equal to square root of 3. And then to find the height of the triangle, we can draw this at right angles to the base. This will be the height of the triangle. And since this is 60 degrees, that means this is 30 degrees. And in every single 30, 60, 90 triangle, the base is 1/2 of the hypotenuse. So this side is going to be √3/2. And then to get the medium side, you multiply the shortest side by square root of 3, and square root of 3/2 times square root of 3 is equal to 3/2. So the height of our green triangle is 3/2. And now we can simplify all this. On bottom, 2 times 2 is equal to 4. And on top, 1 times √3 times 3 is equal to 3√3. The area of this green triangle, it's equal to 3√3/4. And now we know the area of this blue segment. It's equal to the red sector pi/2 minus the green triangle 3√3/4. And now we can clean things up a little bit and add the two blue areas together. It'll be pi/2 minus 3√3/4 plus pi/2 plus 3√3/4. Let's rearrange things a little bit, and this negative 3√3/4 and the positive 3√3/4 are going to cancel each other out. And then pi/2 plus pi/2 is equal to 1 pi. Let's give it a label of square units and put a box around it. And this is the answer to our question. The total shaded area of these two blue regions is equal to pi square units. How exciting. I had a lot of fun solving this one. I hope you guys did too. And if you ever want to try to fine tune your skills so it'll be easier to solve problems like this, Brilliant has you covered. You'll very quickly see how fun it is to learn with Brilliant's interactive lessons and helpful hints and explanations. I love this section on probability and chance. If you don't know much about probability, it's a great place to start. And if you do know a lot about probability, it's still a lot of fun to go through the interactive lessons. I'm always excited to see how Brilliant puts these lessons together. This is a unique format and Brilliant does it really well. And then in this section with clustering, it's also pretty cool. I pretty much forgot everything I learned about clustering in school. So it was really helpful for me to go through these lessons. I'll probably never forget this stuff again. If you want to try Brilliant for free for a full 30 days, visit brilliant.org/andymath or scan the QR code on the screen. Or you can click on the link in the description. If you go through this link, Brilliant is offering 20% off an annual premium plan. That'll give you unlimited daily access to everything Brilliant has to offer. How exciting.